Okay, the very first thing you ever want to do when you see a graph like this is you want to do charts. So I'm going to do a first derivative chart. I'm going to stay in the domain. So the function is defined on this domain, so we know that, from -1 to 4. I'm going to look at what my first derivative quite literally is. Where is it 0? At 0 and at 2. My first derivative quite literally is, remember you're looking at derivative, is positive. And then it's positive this whole time. Remember you're only looking at what it is. This just means your slopes are positive and then negative. So that tells us my function's increasing, increasing, decreasing. Then I'm going to actually do a second derivative from -1 to 4 from this picture. So now I'm looking at this function's, watch my pens, derivative. So now I'm going to look at what this is doing to see what its derivative is. So while this is decreasing, its derivatives will be negative until you get to 0. So now I'm treating this like the original, and then I'm looking at its derivative. While this is increasing, while the first derivative is increasing, the second derivative will be positive. And this looks like these are possible points of inflection because this is where this function's derivative would be 0. While this is decreasing, its derivative would be negative, and while this is increasing, its derivative would be positive. So now we know all about concavity and increasing and decreasing. All right, find all values for which it assumes a relative maximum. We find that through the first derivative. So we know that my function's going up, up, down. So this would be a relative maximum. So there's a relative maximum at x equals 2, and I want to justify my answer even if they don't ask me, because I know that f prime of 2 equals 0. Right here, quite literally, f prime equals 0, and f prime changes from positive to negative. I probably would write out the words on test day. All right, now let's go to the second thing, find where it has an absolute minimum. All right, so we know that this tells us what the derivative is, tells us what our function is doing. So our function is going up, up, down. So we know it's going up, up, down. So the only two places it could have a minimum would be absolute or relative, but this is absolute minimum. The only place it could possibly have an absolute minimum is at its endpoints. And they happen to tell us the endpoints. I know f of -1 is -1, and f of 4 is 1 of the function I can't see. But we know it started at -1, 1, and it went up and came down and ended up at 1. So this is my absolute minimum. All right, so I'm going to say there's an absolute minimum. They only want the value of x. They don't want the whole value at x equals 1, -1. And I would say that's because I know that my function increases and then decreases on its domain because f prime changes, or goes from positive to negative. Let's see what else I said here. Let's see. So absolute minimum is at one of the endpoints. I think I would say that. So absolute minimum must be at an endpoint. And we know that f of -1 is less than f of 4. Okay. So again, we knew that because of our derivative being positive and negative, we knew our function increased and then decreased. All right, and then C, find the intervals where it's concave down. This is why it's so important to go ahead and make your charts when you see a picture, because now I already know concave down and concave down. So I know my function, C, we'll write it down here. And if you're taking notes on this, you can use this whole area to do it. I'm just squeezing it in right here where I can see it. So it's concave down from -1 to 0, and it's also concave down 1 to 3. And then we want to justify our answer even if it doesn't ask it. How did I know that? I actually knew it. My second derivative was negative, but the way I actually knew that is my second derivative was decreasing right here, okay? And so the way I actually knew that was f prime is decreasing on those intervals. And again, on test day or exam day, I would write out the words a little more. But you would want to say, like, from what they gave you, how you really know that. And so remember what the f prime is doing tells you what f double prime is. So f prime is decreasing, f double prime is negative. It's real important, very helpful to go in and do your charts before you start. All right, give all x values where it has a point of inflection. Well, first of all, you want to establish where your second derivative is 0. So how would I know where my second derivative is 0? This is my first derivative right here. And so I would look and see where its derivative would be 0, which would be here, here, and here. So first of all, I'm going to establish that. F double prime of 0 equals 0. And we can see it's not undefined. We can see it levels off. F double prime of 1 equals 0. And F double prime of 3 equals 0. And if you're taking notes again, hopefully you've used, some of the room that I gave you on your handout, on your worksheet. So continuing this one, that still doesn't establish a point of inflection. We have to be a sign change. And the second derivative changes signs at x equals 0, x equals 1, and x equals 3. And then I think I would even say how I know that. And I knew that because f prime changes from increasing to decreasing and vice versa. So what I mean by that is when this changes from decreasing to increasing, I knew that these signs would change. While this is decreasing, its slopes would be negative. While this is increasing, its slopes would be positive. You want to depend as much as you can your answers on what they gave you. And then E, I'm supposed to sketch a graph. So let's see how we can do that. So let's get some room up here of what all we know. What all do we know? So we're supposed to sketch a graph of the original. Oops, sorry. All right, so let's grab some points they gave us. All right, so they gave us these points, -1, -1. So definitely use points you know or that you found. And 0, 0, and 4, 1. And I am so glad that I did this before I started. It's like kind of an evil happy face. I'm so glad I did this before I started, because now I know my function increases and increases till I get to 2. I don't know 2 what. Sometimes they make us find it, but we know that that's a relative max because we already found it. We also know it needs to be concave down, concave up, while it's increasing to 2. And then a little bit concave down until it gets to right here, because that was a negative. Where's mine too? Okay. So I need to go concave down till I get to 0. and then a bit of a concave up to 1. I need to max out at 2, and that's nice because I can make it concave down until I get to 3, and then a little bit of concave up while it's still decreasing.